Let's look at another fault. So again, when the vehicle comes into your shop, first thing you always try to do is verify the operator's complaint. So let's see what we have. My backlights start activating, my tail lights are staying on, and I have no signal lights. So of course, right off the bat, the first thing that should come to your mind is I actually either have an issue with the backbone or possibly a ECU issue. So to troubleshoot this, let's do some pinouts and see what we can find. So the first thing, of course, you always want to do is check your source voltage. So we'll put the meter on DC volts. I put my black lead in my A terminal, which is my ground, and B in my fused power, or B port. And you can see I've got 13.81 volts, which tells me there should be more than enough adequate source voltage to activate the system. The next test I'm going to do is actually check my voltage on my CAN high and CAN low. So I'm going to move my red lead to D, which is my CAN low, and you can see right away my voltage has dropped off to 0.023. But what's the biggest thing you notice is there's no communication taking place. Again, that's reinforcing the fact that for some reason it's not communicating, so whether it's a data bus or an ECU. Let's check our CAN high. So I'm going to move to the C terminal. And again, the same thing. You see I've dropped all the way down to 0.003 volts and actually not fluctuating. So it's telling us there's an issue with it. The other thing I can actually do again now is check my terminating resistors. So remember we talked about we can check the terminating resistors two ways. I de-energize the system, put my meter on ohms, and I'm going to leave one in high and one in low, and check my terminating resistors. So you can see I got 59.2. So we can say the terminating resistors are probably in good shape. I'm going to repower it up. Remember we said because we're doing a reference voltage of 2.5 volts, I can actually check the system. So you can see I've actually got 37.4 ohms in that system. A little bit low, but it's showing me I've got continuity. So we could probably consider the fact that possibly the backbone is in good shape. So in order to troubleshoot this, the next thing we probably want to start to do is disconnect some ECUs. So I'm going to switch back to my voltage, and I'm going to put my ground back in the A terminal. And again, what you're going to do is, we can do this two ways according to your module. One, we can go right down to where we right down to the engine module and see if the engine module communicates, or we can actually go one module at a time. I mentioned to you guys that what we need to do or should do is when we disconnect an ECU is power down the system. So I'm going to shut the key off and I'm going to disconnect the input module. And you can see nothing happened. Okay. I'm going to power down and I'm going to disconnect my engine module, power back up, and no communication came. Power down, disconnect my output module, power up, no communication came back. So what the module says we could actually start doing now is adding the modules back into the system. So I should actually do the last one. Power down, power back up. And you can see I'm starting to get, I'm showing continuity in the system. So we can actually say the backbone's probably in good shape. So the thing we're going to do now is power down, and we're going to start hooking up our ECUs. And you can see we actually got some communication coming back. I'll now plug in my next module. And we still have communication. Let's plug in another module. And we still have communication. And let's plug in our last module. And you can see we've lost that communication. So by doing that test, what are we able to determine? That this cluster module has failed. So you can see just by doing the pin out and watching the voltage come back, I was able to determine that cluster module had failed.